Okay, good day, viewers. You're welcome to Air George Academy. So today I'll be treating some topics, some things on circle and chord properties of a circle. Okay, so let's first define what a circle is. A circle is a set of all points at a constant distance from a fixed point in a plane. So we have let's say these are all points, these are all points from equidistant from this fixed point, and this fixed point is what we call the center of the circle. So this is what we call the circumference of the circle, and the fixed point, the center of the circle. So we need to also define the radius. The distance from the fixed point to any part of the circumference is called the radius. So this is the radius of a circle. Also, there is another property that we need to know, which is the chord. A chord is a line segment that joins any point on a circle or on the circumference of a circle. So when you look at the chord, this is a chord. This is the line segment, and a chord divides the circle into two segments. So this is the minor segment, and this is the major segment. As you can see, this is quite bigger than this. So the minor segment and the major segment. That's the function of the chord. So it's divides is a line segment that joins any 2 points on a circle. Now we have what we call the diameter. The diameter is also a chord, and is also the largest chord that divides the circle into 2 equal halves. So it divides the circle into semicircles. So there is a property of a chord. Now, so I can have a diameter drawn this way. A semicircle drawn this way. This is the diameter. So another definition for a diameter is a line, a straight line that passes through the center of a circle and touches 2 points on the circumference of a circle. So if we know this, let's go back to this chord. I said this is the chord. Each of these segments are alternating to each other. So you can say alternate segment of the other. This is the alternate segment of the major, and this is the alternate segment of the minor segment. So with this understanding, we can also look at some other things like the sector of a circle. This is an arc. A portion of the circumference is an arc. So an arc bounded by a chord is a segment. An arc bounded by 2 radii and sustaining an angle is called a sector. This is a sector. This is a segment. So this is the sector of a circle. And we also have what we call the quadrants. Though we are not going to deal with all these for now. Quadrants. Then there's another thing you need to also note is a line that touches the circle at a singular point. And this line, we call it the tangent. So with this understanding, we are going to use some of these properties to solve questions when we get to the chord theorem. Thank you for watching. Okay, welcome back. Okay, welcome back to this session of chord theorem. So we have been able to deal with two of the theorems. Let's go to the next theorem, and that's theorem 3. Theorem 3. The line which joins the center of a circle to the midpoint of a chord is perpendicular to the chord. The line which joins the center of a circle to the midpoint of a chord is perpendicular to the chord. When we talk about perpendicularity, it means it's at 90 degrees to the chord. So from here we can draw a diagram. So we have a circle with center O and a chord PQ. So we have look at it. This is circle with center O, and this is a chord PQ. So chord PQ with the midpoint. This is the midpoint of chord PQ. That's the center point. That is, when you divide it into at this point, you have 2 equal PT equals to TQ. Now, we want to prove, what we want to prove here in this is that the angle, we want to prove that the angle at OTP is equals to angle at OTQ equals to 90 degrees, because it is perpendicular. So the line which joins the center of a circle, this is the center of a circle O, to the midpoint of a chord is perpendicular. That is, we want to prove that this place is 90 degrees and this place is 90 degrees. So it's perpendicular, although we already know that this place is equal to this place, since it's the midpoint. And so we're going to draw the join OP and OQ. When you join OP and you join OQ, you know these are the radii. They are already given to us. So we have the radii. This is the radius. So radius, you have your OP equals to OQ. That's already given to us, and our TP is also equals to TQ. That's also given to us. These are the given. So you can now see that OT is common to these two. If OT is common to these two, it means OT for this is same thing as this. So this triangle is having same side, same angle, same shape. So if this side is equal to this side is equal to this side is equal to this side, it means this angle is equal to this angle is equal to this angle. Therefore, this angle is also equal to this angle. So what we're going to do now is another corollary. We have corollary to this. The corollary is that if the perpendicular bisector of a chord passes through the center of a circle. So what that means is that this is the perpendicular bisector of a chord. This is the perpendicular bisector. It passes through the center of a circle. So And from the first one we said the line. So when you are given questions of this form, you should be fast to understand that. The other theorem is also like this. So let's take it together. That's theorem 4. And this theorem 4 says that the line from the center of a circle, line from the center of a circle, is perpendicular to the chord, and bisects the chord. The line from the center of a circle is perpendicular to the chord. So let's draw the diagram. We have center O. The line from the center of the chord, of the center of the circle, this is the chord. This line from the center of the circle bisects. When we say bisect, it means it cuts the particular thing you're talking about into two equal halves. Bisect. That means this side is equal to this side, and it's perpendicular. So it's just from what we have already mentioned earlier. So if you have a PQ here and you join this to this, already we know that OP and OQ, they are the radii that have been given to us. OT is common to these two, the points, the midpoint. So OT is common to it, and so we have been given that what the angle here is 90 degrees. So therefore, we can now say that PT is equals to what? TQ. You can say that PT is equals to TQ since the triangles are the same, having the same angle, the same side, same shape. So that is theorem 4. Let's look at theorem 5. Theorem 5. We are advancing. Equal chords are equidistant. Equal chords are equidistant. Equidistant from the center of a circle. Equal chords are equidistant. So we can draw a big triangle. We have this chord. We have this chord here. Let's name this PQ. This is the midpoint of this. We have RS. RS here. And this is the midpoint of. Here is the midpoint of RS. T is the midpoint of this. Equal chords are equidistant from the center of a circle. By the time we draw the point of it, let's call this I. So the distance between TO is the same distance with OU, or the distance between OT. The distance of OT is same thing as the distance of OU. The first thing that we need to know here is that the angle we have the angle at OTP. OTP is also the same thing as angle at OTQ. OTP is the same thing as angle at OTQ. The angle 90. Also, OUR is the same thing as OUS, which is also equals to 90. We have been given this from the other theorem that we have discussed. Then so And since the triangles are the same, then we can now conclude that OT is equals to OU. So I'm not doing much of the proving here. I just want this is just like a revision for you to know some of these theorems and how they come to play here. So the next one is Theorem 6. Theorem 6. This Theorem 6 says that equal chords of equal circles are equidistant from the center of the circle, or in equal circles, chords which are equidistant from the center are equal to each other. So it's just a way of repeating Theorem 5, that chords equal chords of equal circle. These equal chords that they are equidistant from the center of the circle. So we will not touch this again, since we have been able to prove that under Theorem 5. So with this, we also need to note the next theorem that we need to know is theorem, let's say Theorem 6 now. The angle which an arc subtends at the center of a circle is twice that which it subtends at any point on the circumference. You need to understand this very well. It's Theorem 6. So if you have a diagram, let's look at this diagram together. This is an arc AB. An arc AB. Let me see. Do I have a black marker? Okay, arc AB. This is arc AB, and this is the center. This arc AB subtends an angle at the center O. The same arc AB subtends, so you can see it subtends an angle at the circumference of the circle. Let's call this P. Point P. What we do here is, let's look for a way of dividing this. If we divide this, there are so many proofs to it. We can see that this is a perpendicular, this is a radius, this is also a radius. That means, since they are both radii, these are two radii for this triangle, AOP, you will notice that this is an isosceles triangle. So in an isosceles triangle, the base angles are equal. That means that if this base is S1, then this is S2. Both of them should be equal to each other. S1 equals to S2, since they are base angle of isosceles triangle. Base angles of isosceles triangle. Now, this, let's call this place Y1. This is also, this is a radius, this is another radius. Since this radius and this radius with this line form another triangle, which is also an isosceles triangle. The base, this Y2, Y1 equals to Y2. Same reason, base angles of isosceles triangle. From here, we can see that from line geometry, one of the theorems says that the exterior angle of a triangle equals to the opposite interior angles. So from here I can say that this angle here is equals to, let's call this A, let's call this B. So A equals to S1 plus S2. Then B equals to Y1 plus Y2. Now, from here, since S1 and S2 they are the same, I can say A equals to 2S1 and B equals to 2Y1. 2Y1. So from here you can see that from the reflex, this is the reflex angle now. Anything I want to do. Some of these videos.
How did you start this video?
Huh?
Have you started by yourself?